Today we will present and show in this video how can make mission planner configurations. First of all, we connect our flight controller to ArduPilot in COM6. After we go to steps, first of all we go to frame the type of our frame. So we select the class and we select also the type of our frame. There are a lot of parameters and a lot of frame types. In our application we are using X frame. After that we go for initial tune parameters. So in this we can see here a lot of parameters of battery. For example, battery cell count, how many, battery cell full charge voltage how much, and battery cell for the charge how much. For example, charging 4.2 and the charging battery 3.3. okay, and the type of battery is lipo. This most parameters for any drones. After we go for
place vehicle level and press any
drones.
key.
First of all, we keep the drone leveling. So step number 1. After make leveling, we go left side as the
error compass variance
in the right of screen. After we go to right side and we arrange the right side of the drones. After that we go for noise down. Make sure our drone is 90 degrees with the ground in this noise down. After that we go for noise up, so we make sure our drone is noise up. And finally we make backside, our drone in backside. Like this we finish all the calibration parameters of our
error compass variance.
So we receive now notification of successfully
calibration successful.
So we have successfully. Okay, so we go for now check. Yes, we move our drone and we can see the screen now. If you change the interface, change up, down, left, right, we can see now the ground and is leveling now. And now we go for compass calibration. So in our application we have GPS module 5883L and we'll try to make our calibration for Mag 1. So we rotated drones in different position, but the best and the most important parameter in this application will should make the calibration outdoor. So I will try to make drone calibration, GPS or compass calibration outdoor, not inside door. They take times between 2 to 4 minutes, and but give you a lot of parameters and give you a lot of accuracy when using the autonomous mission planners to fly your drone from one place to another place. You should be have compensations successfully. Okay. After that we make reboot your compass. Okay. Now we go for step very interesting, the radio calibration steps. So first of all, we should make sure our transmitter is on and we don't have any propellers in motors, and we'll try to make our test. So we'll change all the switch up down of our transmitters. All will change it, and we will see the minimum value and the maximum value for each switch and each parameters. After that we make or we click in the calibration and we make sure the throttle is down. We keep the controller of throttle down. After that we make OK, and we see we have our calibration. Now we go for another step, the fly mode. So in channel 5 as we have here. So we have 5 modes, sorry, 6 modes. So fly mode number 1, stabilize, and we can go for fly mode 2 for RTL. Fly mode 3 is landing, and fly 4, 5, 6 we can change it according our specification and according what we need. We can make like acro, and finally we make completed. So we have our fly mode. Now we make calibration with our transmitter, and we are sure the matching between flight controller and our radio frequency transmitter. So now we'll change the switch, and you can see now we go for fail safe mode. If battery lower than value, so what we should be do, so we can go for RTL or landing. So we can, in our application, we can make landing. Another application we can make like return RTL, means return to original position. This all parameters, so we have it in our drone. Now we go for another parameters. We check the battery monitoring here, so we can change a lot of parameters for our battery monitor. Also we can go for range parameters, and you can see now our platform
Radio fail-safe.
and
Disarming.
our systems. We make deconnected now. We disconnect the ArduPilot from the flight controller, and we will see what happened, and we'll connect it again.
Radio fail-safe cleared.
So we can see now all the alarm is coming in red colors, and the white means
Arm. Battery 1 low
our
capacity
situation is okay.
fail-safe.
So our mode is acro, and
Arm.
pre-arm,
Battery 1 low
and we have
capacity
battery low
fail-safe.
capacity fail safe. So this parameter should be checked, and recalibration before make any next step. So we can see stabilize now, change the
Arm.
mode stability.
Battery
because
1
we
low
changed
capacity
already,
fail-safe.
our parameter for
Arm.
our
Battery
transmitters
1 low.
device. So now we go for full parameter list, and we can go for battery check. So we check and we change the value of batteries according to the battery you have it in your drone. You can change this. We have Excel sheet can help you to make a lot of calculation of your battery levels. So battery saddle voltage, battery low milliampere hour, battery low timer, and battery low voltage. So we can change according the class of your battery. For example, your battery S2, S3, S4, S5 or S6. This all parameters change. But we have Excel. I will put the link, and you can see this link if you need it. The Excel sheet can generate all these parameters. Now we can see now if the
Arm.
problem is
Battery
still
1 low capacity fail-safe.
or not. Until
Arm.
now we have the same
Battery 1
issue.
low capacity
So
fail-safe.
we go for configuration again. Okay, and we make battery. So we added the battery again. Yes, for ARM. Okay, and battery capacity. Battery capacity you can change 3000 milliampere hour, 6000, and low battery low ampere hour. Okay, should be added also. This is one of the most parameters, and you can change, for example, according to what you have battery 6000 milliampere hour, and save. Okay, this new parameters, and you go for data and deconnected now our flight controller and reconnected again. Okay, deconnecting and connecting again, and we'll see if everything is okay
Arm.
for our
Battery 1
application.
voltage
This
fail-safe.
very
Critical
interesting
equals low.
parameters
Arm.
we should
Battery
be,
1 voltage
do
fail-safe.
before
Critical equals
start
low.
and before fly any drone. This most. Now we go and check all the parameters of the battery and change it. So okay, we go for battery cellular voltage. Okay, so we make all the parameters. Okay, we change 13 to 14. Okay. And we're writing in with battery low voltage. Okay, and we change from 10 to 14. Okay, so low voltage 14.4 and critical 14. And we make now, we go for if you have any issue for battery fail safe, we'll change 1 for landing and 2 for RTL. So we change now from 0, okay, to one of the parameters according to your application. So 1 landing, automatically landing, or 2 to RTL. Okay. Also if battery fail safe low, so you can make 2 like RTL. Okay, so you have two chances. Okay, now, and we'll check everything. So we hope now data it is very clear and we don't have any error coming from the ArduPilot. Yes, now we are ready, and all parameters until now is working very well, and we can arm. So arm it now. Our drone is armed without propellers in the ground,
thrust loss
and can check this thrust loss to some. We have some potentials which should be changed, and some parameters should be taken in our consideration. We can see here GPS not fixed because we are testing in our lab. We are not testing outside, so we don't. The flight controller and GPS cannot detect any satellite because we are working indoor applications. So all these parameters, necessary parameters, should be taken in our
mode change to RTL failed. Requires
labs
position.
to control.
Mode change to RTL failed. Requires position.
Configure any mission planners. And you can see now RTL stabilize, so we change a lot of parameter, and we can see what we have.
Mode change to RTL failed.
Platform,
requires position.
We can make
mode change to RTL failed.
So now we go for fail safe, or we can go for motor test. We can test motor number 1, okay, and we see if counterclockwise or not counterclockwise according the type and of our drones. We go for motor number 4 and see is counterclockwise or not counterclockwise. And if this parameter is not calibrated, we should be change it and make sure motor number 1 counterclockwise and motor number 2 counterclockwise, but motor 3 and 4 should be clockwise. And also this another parameter should be taken into consideration, the propellers. So propellers should be take care about marking for any propeller. There are some marking, for example for time motor, air marking for clockwise. Okay, so all clockwise should be
potential thrust loss 2.
Propellers
potential thrust
with
loss
marker
2.
like air means counterclockwise. This all what you have. If you have any question, you can contact us, and we can support you to prepare and to configure your mission planner for any drone testing. Thank you.